So let's go. Okay, so as I said, the session will be about evaluating functions. One thing about the 1.1.1.2, which is basics of the functions. And what I want you to remember or keep in mind is that how a function is defined. Usually we have f of x equals to a formula or some formulas in x. And what does that x do here? Don't look at that guy as a formula. It's not a formula. It is a recipe. What it does is saying that, okay, whenever someone puts in x, I will do some operations on x as this formula tells me. In other words, x is just a placeholder. Well, for example, this function that you have, f of x equals to x squared plus 1, what it says is that whatever I give you, you square it and then add 1 to that. For example, if I put f of box, you square box and then add 1 to that. Okay? And well, if I give you the chair, you square the chair, add 1 to that. If I give you myself, square it, add plus 1. So whatever the input is, you square it and add 1. And the second comment that I want to add here is the piecewise defined functions. So piecewise defined functions are something that you have to know. We will do some examples today on that, and you will see how this works. Now I'm getting worried that the recording won't be just okay. Let's see how it will show it. Okay, so easy examples. What is a function is f of x equal to x squared plus 1? What is the value of the function at x equal to 0? So we are basically looking for f of 0, and what just input is a 0, so square it, add 1 to that, so it will be 1. How about this guy? Okay, g of 4, that's the what question asks. Value of the function at the given point. G of 4, it is root of 4 over 4 squared minus 2. And this is 2, square of 4 is 2 over 16 minus 2, which is 2 over 14, and it is 1 over 7. And okay, we got to the piecewise defined functions. In these functions, which I'm assuming that you have worked with these functions before, but quickly I will review what is going on. In this function, you have different formulas for different range of x. Well, meaning what? For example, if you're looking for h of 2, you don't start with the formulas. You start with the range. Is x equal to 2 in this range? Is it maybe in this range? Or is it here? First, find the range to which the given value of x belongs. So here, this is the range. When you find that, the corresponding formula is the formula you have to use to evaluate the function at that point. So it will be 2 squared minus 2, which is just 2. How about h of 0? Well, 0 is less than 1, so it is here. I will use the corresponding formula over there. So it will be 0 minus 3, which is negative 3. Okay? And here now we have a question. Sinan, could you please run the question 1? Yes, okay, so I will give you 45 seconds. Make sure that you know the function. What is the function? That's the function h over there. And the question asks, find h at pi, that's the pi number, -3. Okay, go ahead, find the answer and put it in the poll. 10 more seconds.
We're only halfway there, so should I end the poll?
Yeah, okay, good. So about 59% answered pi -6, which is good one. So what happens here is that you don't need to know the exact value of pi. And by the way, no one knows what is the exact. Oh, no one can say it. You never finish it. Yes, there is no. But what you need to know is pi is approximately 3.14, and pi -3 is 0. Approximately. Again, this is not precise. So what it has for me is that this is a number definitely less than equal to 1, less than 1, sorry. It means that this number, pi -3, belongs to the first range of x. That means that I can use the first formula. X, whatever is here is my x, pi -3 minus another 3. That will be pi -6. And some of you may say, okay, I want to write 3 points. I want to use the calculator and put the exact value. You don't need to put exact value there. And you cannot put exact value there, by the way. You write pi -6. This is the most precise answer you can give to this question. Is there any question, any comments related to this topic?
By the way, if you have questions during the lecture, you can just write them on the chat and I'll read it at the end, at the question session.
Okay. Do we have anything now or you will do it later?
I don't see anything.
Okay, good. Why do we have 33 comments there? Something. Okay.
They're organizing a group chat for the course.
What?
Okay. On Instagram.
Okay. Okay, so let's just go back again there. So the second thing that we want to cover or we want to review is graph of functions. So what does we do? What we do is this. When you have a function, you find all the points x f of x, and you put all these guys together such that x is in a domain, well, that's, I will explain what is that, of f. And these are points. So if you have your Cartesian coordinates, you will find points, 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 points. You add more points there, more. And then if you have more enough, this will look like a graph or curve. That's called the curve of the function. What kind of graphs you need to know or how to draw? At this stage, you need to know how to sketch lines or linear functions, which is f of x equals to ax plus b, sketch a parabola, which is graph of quadratic functions, f of x is equal to ax squared plus bx plus c. You also need to know just these functions themselves, x squared, x cubed, x4, and so on. And that's, if you know how to do these three, you're in good shape. You can go ahead and start this course without any worries. Something that here we will discuss will be sketching a function, piecewise defined function. And the second thing will be how the transformation of a function can help you to find the sketch of the graph. So transformation and the graphs. So if you know how to work with these ones, you're very good. Later on in the course, we will have a full chapter or half chapter of how to sketch a given function, all the tricks, all the things that you need to know to be able to sketch the graph of a general function, a function that you can write down and make sense for you. Those are, that will come later, but at this stage, you just need to know these ones. Okay, as examples, let me start with this one. This is piecewise defined function. And when it comes to piecewise defined function, you may say, okay, there are two things here. I can go ahead and do the line, and I can go ahead and do the parabola. Which one do you want me to sketch? Okay, for this one, you have to sketch both of them. That's a lie. But you start from there, and then I will tell you what to do. So, for example, y equals to 2x minus 1. This is a line. To sketch the line, you need to find 2 points of that. For example, when you set x equal to 0, you will get -1. So this will be 1 point. And another point will be 1/2. So if this is 1, this will be another point. So this is the line I am. Okay. And the other one, the parabola, okay, I will try different color there. 2x minus, okay. So when you have parabola, you have to first find the x component of the vertex. That's minus b over 2a. So minus b over 2a. That's b is -2 minus b. So that will give you 1. And when you find that, plug in 1 there, here, you will see that 1 squared minus 2 plus 2, this is 1. So that tells me that it has a point here. And then you add 2 more points. For example, 0 and 2, and 2 and 2 will be 2 more points. Okay, so here is what you will get. Here is what you will get. Okay, very nice. Okay, I sketched, but this cannot be the graph of one function. Why? Because use the vertical line test. At every given point, that will intersect more than 1 point. So that means that it's not the graph of a function. But here, we are looking for x bigger than equal to 0. X bigger than equal to 0 is here. So for that part, we have to get rid out of the parabola thing. So this means that I can raise this guy and raise it. Okay, like that. And for x's less than 0, I have just parabola, I don't have the line. So I need to get rid of the extra piece of the line there. Always when it comes to piecewise defined functions, the point, the separating point, in this case, the 0, the separating point of the intersection, the domains, you have to be very careful to include on which part of the graph. Here, x equal to 0 is included on the first one, so the line should have a solid bullet over there. But x equal to 0 is not included in the second part. That means that we won't have that point over there. So it will be just hollow bullet there. And that's the graph of this piecewise defined function. Sinan, is there any question that I stop here? Maybe.
Not, I think, about the example here, but general organizational questions. For instance, one person asked, is it okay to...
Is that okay? Let's keep them for the end.
All right, perfect.
Okay, great. Okay, so that's the one. How about this other one? Okay, g of x. Okay, I will need extra space here. So, well, this is not any of the functions I mentioned above. So how you're expecting me to draw that one? Well, what I'm expecting you to know is first that you know the absolute value function. Absolute value, whatever you give to that function, it will give you the positive side part of that one. Means that if x is a positive number, you just get that number back. So output would be the same number. But if x is negative, this is so fun. This is how crazy mathematicians are. They cannot say drop the negative sign. The formula, we don't have anything for drop the negative sign. But the trick is that you multiply that negative number by another negative sign. That way you will get rid of the negative sign. So I'm expecting you know what is the absolute value function. And the graph of that, as we did above, that's a good thing for you to check here. The graph for that is this guy. And you have it there. But how is that related to my function? Okay, if I start with the absolute value function, okay, then I can apply some transformation and get gx. What are the transformation? First, I replace x by x minus 2. This way I get x minus 2. And then I multiply whatever the function is by 3. Then I will get 3x minus 2. And then at the last step, I will add 3 to the function. And this way you will get 3 times x minus 2 plus 3. And this is the function we are interested to, okay? So we want to sketch the graph of that one. Now we can go ahead and understand what each one of these transformations.
There's a small correction, it's +4, by the way.
Oh, is it +4? Thank you. That was good. This is +4. Thanks. And Now that you have that one, so you should go one by one and see how this transformation changes the graph. For example, if I switch x to x minus 2, this will be first horizontal shift 2 units. Is it to left or right? Sina, you should tell me if we're getting good answers or not.
We have one left, 4, 5, 6, 7.
Okay, good.
The rest is going right.
To
So
the right, yes. And that's what it will do to the graph of this function. How about multiplying the whole function by 3? This is a vertical stretch by factor of 3. And that's it. How about if I add 4 to the function? This is vertical shift. This will be 4 units. It will be upward. Now that we know all these things, we can go ahead and do one by one change the graph one by one. So for example, here, the graph, we know that it started with this thing. Yeah. Now we are shifting that to the right. So I will copy this and then paste it here. And when I'm pasting, I will shift the function, that part of the graph of the function, to 2 units to the right. Well, just to show exactly what I'm doing, it's better to find some reference points and keep track of how these reference points changing. For example, 0, 0, now we'll go to 0, 2. And when I do this, I will get a different y-interception. How about I write what is that y-interception? In this case, this is going to be 0, 2. Why did I add that one? Because I want to keep track of that reference point and show you what is happening in the next steps. Okay? Now, the third step is that, okay, we want to stretch that. Copy, paste. We want to stretch this guy upward. Okay, so I first need to choose this one here. Okay, this is something that I can do here in the computer. Okay, stretch it up. Well, the numbers over this point will be changed, will be different, or will be 0, 4, but that's how stretching goes. Now, why 4? 6. Everything is multiplied by 3. Sorry, this will be 0. Maybe then I will do a little bit more stretching. Okay, stretch a bit more. What? No, doesn't work. Okay. Okay. Go to 6, something like that, yes? And that new point now is going to be 0 and 6. The reference point 0, 2 went to, and 2, 0. Oh, I am missing. Okay. This is 2, 0. 2, 0 stays the same. We'll keep the same thing. Now, the last step is that shift everything 4 units up, and I will do that one. Oh. Okay. copy and then paste. This is what we have. Now I need to just shift these guys upward. Well, just a unit of 4. Oops. Something like that. And then when you shift that, just again, I have to tell you what will happen to this point here. This will go to 2 and 4. And 0, 6 will go to 0 and 10. That way we have the sketch of the function g. Okay, so these were 2 examples that I wanted to do. First one was related to piecewise graph of piecewise defined functions. The second one was how the transformation can be used to find the graph of new functions. Do we have any questions related to this topic?
Yes. First one is, what order should we apply the transformations?
Oh, I like that question. And I always have an answer for that, not a good one. Because, okay, so let me make this thing go down a bit, and I will push you down there. So for me, I never give you any specific order for the transformation. The point is that in any order you want, you can do these transformations. But you have to be careful. If you change the order, you may need to change the transformation itself. So I'm not going to give you any order. And in another example down there, we will see that how changing the order of the transformation can affect the transformation you need to apply. So if you're expecting me to give you an order like your high school teacher, I'm sorry, you're in calculus 1000. You have to know a little bit more than 1000. I will explain a little bit more later in another video, in another example.
Rest of the questions were also related to orders. Someone said they did the vertical stretch first and then translations for this specific example.
Oh,
and asks if that is okay. Yeah.
Okay, so if you give me that order, I will tell you what would be the difference. Okay, so first, did which order?
Vertical stretch.
Oh, they did vertical stretch first?
And then translations.
And then translations, okay.
It should be fine, I think.
Yeah, well, the point is that, yes, I know that to go from this to that, I need to do what? Multiply the whole function by oh, by the way, for this one, it won't change anything. Yes, in this, if you change the order the way you said, it will go right the way that the one we had. Look, so here will be f goes to 3f, and then you have 3x plus 4, then f goes to f plus 4, and then from there you change x to x minus, what was it, 2? 3x minus 2 plus 4. That's why I said in another example. In another example, I'll show you exactly what I mean. But if you change, in this example, if you change the order, the transformations say the same thing, at least in this order that you saw. Any other?
Sorry, one just popped up. So I can safely assume that you transform according to the ones in bracket first, and then on the outside of the bracket.
That's a good strategy to take. In general, that will help you to do nice things, but sometimes you have to be still a little bit more careful. I will, in that example, I will explain a little bit more. But for me, myself, is go in the order that you do the operation. So that will do some nice work for you. If Sinan, if the questions are in that direction, let's just leave them.
There's no more questions about this example, but there is one organizational small question if you want.
Related to the assignment question?
Yeah, so they have some questions about the quiz and other topics in the course, and they're asking if they can ask those questions in tutorials.
At the end of the tutorial, if we have time.
Yes, that's what I said exactly. All right.
Thank you very much. Thanks. Okay, how about the domain? Well, domain is a fancy word. Domain of a function is fancy word for what are the acceptable values of x. Values of x. And in the level that we are now, there are two things that you have to know. The restrictions that we have to apply. One is that no one on the earth is allowed to put 0 in the denominator. So in other words, the denominator must be non-zero. That's not me, that's not you, that's not any other instructors in this course or any of the people from the math department. This is a rule in the whole world. You cannot divide any number by 0. The second one is the number or the number in the square root or any even roots must be non-negative. Well, the second restriction is not a big deal in general, especially if you know very advanced math called complex numbers. There's no issue over there. So there's nothing there. But for us, because we're working with real numbers, we cannot put negative number under a square root or any even root. Okay, so these are two things that you have to have in mind and use those ones to find the domain of given functions. For example, here this function is a fraction, so it has a denominator, and we know that the domain should be all values of x such that the denominator is not 0. That's the first restriction. The denominator must be non-zero. Well, what kind of x's that will give me? So x squared minus 3x plus 2 not equal to 0. Not equality, you can solve them very exactly same as the equalities. So you do the works you do for the equality here and solve this one, meaning that, okay, I can factor this guy, x, I'm looking for two numbers adding to -3, and when you multiply, you get 2. This will be -1 minus 2. From there, you get x minus 1 not equal to 0, x minus 2 not equal to 0. From here, you get x not equal to 1. From here, you get x not equal to 2. So the domain is all x's, but these two numbers. In other words, the domain is any number from negative infinity to 1, I should exclude it. That's why I use the round bracket. And from 1 to 2, I'm excluding 2, and from 2 to plus infinity. So that's the domain of this function in terms of the intervals. How about the function g in this case? Okay, for g, we have a square root, so we have to make sure that we only picking values of x for which the expression under the square root is non-negative, either 0 or positive. To find these inequalities or solving inequalities, there is one general method, which is find the sign table. What does sign table mean? It means that find where this function is positive, where is negative, and where is 0. So we always start with 1 minus 2x is equal to 0, which gives me x is equal to half. Then I will go, well, there are different ways of doing sign table. I will use the one that I use in the videos, which is probably a little bit different than the book, but I will go with that. So this is values of x goes from negative infinity to half, then plus infinity. When I plug in x equal to half, the function 1 minus 2x is 0. And then I pick some sample points. For example, here I can put 1, I can put 0. So evaluate the function. 1 minus 2 times 0 is 1. Here is positive. So if the sample value is positive, the function, all the values of the function on that part will be positive. If the value of the function in the sample, in this case, -1, is negative, or 1, if it is negative, then everything in that part of the domain is going to be negative. Why did you find the sign table? Because aren't you looking for where this function is positive? Well, that's what it is. It says where it is plus, where it is minus. Now, we can go ahead and see, okay, I'm interested on the positive part, but it can be 0, so I will include that one. So that means that domain of this function g is minus infinity up to half. Do I include 1 over 2? Yes, we do. Okay. Is there any question on this part?
So one thing came up. So throughout this course, I don't think complex numbers are involved. So they asked if this restriction holds or will there be complex numbers in the future?
We won't consider complex numbers at all in this course.
One question popped up right now. Why do we include the interval 1, 2 in the first domain? Isn't it the same thing to leave it out?
Well, okay, so the point here is that we are interested in, so under the square root, we can have any positive number, and we are allowed to put 0 there, aren't we? We can say, okay, look, square root of 0 makes sense. Square root of 0 is 0. That's why I'm taking all the positive things, and the value which makes the function 0. The value which makes the function 0 is 1 over 2. That's why I included 1 over 2 in the.
So Theo says not the second question, the first one.
Oh, the first one. Oh, the first one, is the denominator. Is this one? Yes, you mean?
Yeah, I think his question is why we're splitting and writing the domain as a union of different intervals. I think it's about the points 1 and 2.
Oh, I see.
They
Okay.
are excluded from the domain. So
Yes, okay. So the point is that, okay, I now know that the domain is all x's such that x can be any number but 1 and 2. Yes. This is one way to write that domain. But if you want to write it in the interval format, then you have to write it this way. And you will need to write that one in that format. It basically means that everything but exclude these two guys here, 1 and 2.
yes, someone asked, can we just write it as x cannot be equal to 1 and 2? And then, oh, sorry, they also asked, never mind. So
Okay, yeah, good. But well, in general, in this course, you have to know both interval notation and set notation. So specifically when it comes to the web work questions, you have to know how to write sets in the interval form, because most of the time you will see interval format. But in general, you have to be able to switch between these two notations, different kind of notations. Yeah. Okay. If there is no other question, we can move to the.
I think that's it. Yes.
Okay, perfect. How about?
Sorry,
Yeah.
Theo just wrote something in the last second.
Okay, sure.
Minus infinity 1, interval 1, minus infinity 1, union 2 plus infinity doesn't is already not include 1 and 2 because it is not square brackets. It doesn't include everything between 1 and 2 though. So.
Oh, you. What was that? Negative infinity 1 and then union 1. Oh, union.
The interval 1 and 2 and infinity.
Okay, yeah. This. Okay. So here is something that you have to be very careful. When I write interval anywhere in this course in math, when you see intervals, you're working with real numbers. Who can tell me how many numbers are in 1, 2?
Yes, chat.
Is it? Yes, in the chat.
No one is answering, so. Yeah, someone said infinite.
Yes. If you're thinking only about integer numbers, there is no integer number here. But there are infinitely many real numbers there. So, for example, 1.5 is there, 1.7 is there, or even root 2 is there. What else? Root 3 is there, pi minus 1 is there. All these numbers are there. So there are infinitely many. Actually, there are as many numbers as the whole real number has. So that's why you have to be a little bit careful when you're using the interval notation. You're working with real numbers, and there will be lots of those numbers in each interval. Okay, can I move to the next topic?
Some other questions popped up, but I don't think I understand all of them. Someone said, can't we just write x cannot be 1 and 2? Wouldn't that suffice?
I said when you're doing the assignment,
Yeah.
well, that will work. But when you're doing the, for example, web work quizzes, you have to be careful because you have to be able to translate it to the interval format.
Other questions? Sorry, guys, I don't understand the question. So what do you mean by different notation? No, Terence? And I don't understand your question either, Juan. Sorry.
Okay, maybe you keep the questions for later. You can ask if we have time.
I'll try to answer if I can in the chat.
That would be nice. Thank you. Thank you. Okay, for the range, well, range of a function is a fancy word for the all possible values of that function. That's just fancy word, range of f. And to be able to find these things, I'm expecting you to know two methods. One is inverse function method. Well, what does it say? It says that if your function is nice, you can find the range by doing these old tricks. So you first write this one, solve it for x. It means that you write x as some function of y. Then switch x and y. So you get y equals to hx. And then from there, find the domain of h. So that way, domain of h, which is basically the inverse, will be the range of my function. So let me just write it here. Range of the function f is the domain of its inverse, if it has inverse. This method is nice. You will see that we will do some examples for that, but it's difficult in most of the time because the function, if the function doesn't have inverse, what are you going to do? And also there are this part, solving equations is not easy. There are equations that no one can solve it explicitly. So that means that, okay, this method has some issues, but in some cases, as you will see, it will work. Another one is that use the transformation. Well, we will do an example also for that to show you how this works. Okay. So let's go for this. For example, this one, we have the function f of x equal to this. So I'll start with f of x. So I will have y equals to x squared plus 1 over 2x squared minus. And from there, I'm trying to solve it for x. So I multiply this one there and x squared plus 1. So this way I have x squared minus y, x squared plus. Why are you doing all these things? Well, I'm separating x. So I will bring everything which has y to the other side and everything which has x to the left side. So this will be 2yx squared minus x squared equals to y plus 1. And then go ahead from there. You will see that I can factor out x squared. And then I divide this to the other side. Well, I didn't solve it for x itself, but I solved it for x squared. But from there, then it's easy. You just go ahead, find the square root of that. Now, this is what we found, and now you switch x and y. And you have, oh, I should have done that a bit better. So 2x minus 1. Now, you have a function which is basically the inverse of that function, and you want to find the, oh, okay. I will need a charger for this. Can I just get 1 second here? I need to bring my chargers here. Just a second. Don't go away. Okay. And I will do this one. Mhm. Okay, sorry, I should go. Okay, so now you have this function. You want to find the domain of this guy. So domain of this, let me use here, domain of root x plus 1 over 2x minus 1 is the values of x for which the expression under the square root is either 0 or bigger than 0. Okay, and now here's again, I need to find sign table for this. To find the sign table, we start always from find all the roots of numerator and the denominator. So in other words, we get x plus 1 is equal to 0, 2x minus 1 is equal to 0. From there, you get x is equal to negative 1. From here, you get 1 over 2. Then you list all the values there. You get negative 1/2 plus infinity minus infinity. And we have x plus 1, 2x minus 1. We know that when we put x, when plug in negative 1 for x, the expression is 0. But we cannot plug in half in this equation. This is not defined. And then we need to find sample points here will be 1, 0, and negative 2. Plug in the sample values there. For example, if I plug in 0 here, you get negative 1. So this part will be the whole negative. This will be plus. This will be plus. Now that we have that, we are interested in just positive sides or 0 side. And that's what we have. In terms of the interval, this will be negative infinity up to negative 1. Do I include negative 1? Yes, that's all right. Or from half to plus infinity. Do I include half? Well, at half, the function is not defined, so I cannot include. That's the domain of this guy, but we know that the domain of that is going to be range of our original function. So this is what we found there. Okay? Does it make sense? Okay. So we have another question, but I will give this as a challenge for our second question, second poll question. So let me, actually, I have access.
Before that, Mohammed asks, why did we get the inverse?
Oh, that's one trick. The point is that if you find the inverse and find the domain of the inverse function, you have found the range of the original function. Domain function, finding domain of a function, most of the time is easier than finding range. So if you can change the function to its inverse, you can find the domain of the inverse. That will be range of your original function.
Another question as a follow-up to this one is, can we always take the inverse to get the range, or does it not work in some cases?
In almost all of the cases doesn't work. In very specific cases, this will work for you. So very simple cases would help you to find the range. But in general, finding range is not easy. That's something that you have to know. The best way to find the range is what we will learn later in the sketching graph of a function. When you do the sketching for the graph, you can, the information you found, you can use them to find the range of the function. That's the most general way to find the range of a given function. But if you don't know that one, there are just few cases that you can do. And this is one of the tricks.
So there's a question about grading. I think in assignments, do we have to show why the range is what it is, or can we use our own logic and write down the range?
Use what? Sorry?
Use their own logic and write down the range.
Use your own, whatever you know, but you have to put enough details down. If you don't put enough details down, I don't think you will get good part of that answer, even if your answer is correct. We are not interested in final answer. We are interested in how you got that answer. Use your own way, doesn't matter, but show the details and make sure that you explained it enough.
Final question is, how do we get the domain of the original function? Do we just eliminate the denominator?
Yeah, well, make sure that the parts, you exclude the parts that makes the denominator 0. So this will be 2x squared minus 1, not 0. This will be x squared not equal to half. That means that x cannot be plus or minus 1 over root 2, which is not root 2 over 2, neither plus nor minus.
I think that's it.
Okay. Okay.
Yeah.
Okay, I have another question here. This I will put as a challenge for you guys. Just 1 second before I post that. I kind of got the feeling that this is, I am changing something here. Yeah, okay. That's exactly what I noticed. 3. Okay, so let me just edit this one quickly and then redo. Why did it go there? Oh, okay. Unfortunately, this doesn't have the right answer. Maybe if I change this guy. Okay, okay. So let me just change one piece of this. 3 and then 12 plus. Yes. Okay, so this is the question. I will give you 2 minutes. This is a good challenge. And you need to find find the range of this new function h. We know the range of g. We want to learn what is the range of h.
has been 2 minutes.
Yeah, just 10 more seconds would be.
Right. Because majority seems they haven't answered. They only got 11
Yeah, that's
votes.
very low. Okay. Okay, few more. Go ahead. 4 more. I need 4 more.
Someone asked, by the way, will you upload the recording right away
No,
to the
just
OWL?
take time because I need to clean it a little bit and it will take a little bit time. Okay, good, good. Okay, let's see how this works. The key point here is that all X-related transformations these do not change transformation does not change the range. So that's one key point. And what about Y related? Well, depending on what is happening over there, it would change the domain in the range in different ways. For example, okay, let's just go on this one. If I start from G, then I need to go to G. Well, let's say I multiply X by 2X. So replace X by 2X. And then if I want to do the translation, I have to do X minus half because I'm replacing there. It will be 2 times X minus half. That way you get 2X minus 1. So this will be G 2X minus 1. Then the next step is multiply whole function by 3. This is 3G of 2X minus 1. And then add fourth function. So F goes to F plus 4. So this will be 3 of G 2X minus 1 plus 4. Okay, so this is how we get to the function hx, but we know that this is x related, so the range, we started with -4 and plus infinity. The first operation is x related, so it won't change the range, it will stay the same. Because either you're shifting or stretching horizontally, it doesn't change the possible values for y. And the second one also won't change the range. What would change the range for the first time is this stretch, vertical stretch by factor of 3. It means that you multiply everything by 3, so this will go up to -12 plus infinity. And the last step, you add everything 4. So it will be -8 plus infinity. So the range of h is going to be -8 to plus infinity. That's, I guess, the last question that we wanted to cover today. Is there any questions, Sinan, at this stage?
No, but maybe we should give a few seconds.
Sure, sure.
Actually, Li Min asked, isn't 2x minus 1 the denominator? Then why did you make it 0? I gave a small explanation in the chat, but if it's unclear, maybe we should elaborate.
Okay.
It was about the previous questions you solved.
Okay. Do you want me to go explain a little bit more? But
I don't know. She
okay,
didn't answer.
okay. Thank you for answering that.
So one question is, could we ask a question about the quiz now? So,
Sure, go ahead.
and wait, I think there is a question about this problem. Can you please explain again why -12 goes to -8 on the range? The sound was laggy on my side.
Okay, so we are adding 4. So we are shifting everything up 4 units. So we are adding all the values of y plus 4. So this goes from -12 to infinity. Now, if you add everything on that interval, 4 units, it will get -12 plus 4. Starting from that point, I will go up to infinity. Everything will shifting 4 right. That's why you get up to plus infinity still, and this will be -8 and plus infinity.
Another question is, why don't the x-related operations affect the range?
You see, range is possible values of y, yes? So if you have graph, the range of that function is all the possible values of this guy, okay? So if you shift to right or left, you're changing the values of the function, but the set of the values won't change. It will stay the same because the same line goes up to here, say here, and same value before was value of y was taken here. Now it is shifted a little bit to the left. So in general, the x component either stretch or shrink or shift or even find the reflection about the y-axis, none of them would change the set of possible values for y, which is the range of the function.
So they ask, wait, if g of x's range is given, how can you find h of x like that? What was the connection between their two equations?
No, it was given. It was given as like that. Is that the question? Maybe Sinan, I missed the question.
Maybe you should read the chat. I'm
Sorry,
reading
okay.
code by code. Wait, if g of x's range is given, how can you find h of x like that? Like what was the connection between their two equations?
H of x is given.
Yes.
H of x is given that way. I'm not finding it. I'm taking this, and the question asks to find the range of that function.
One question related to this one is, so if using the inverse doesn't work, then do we just show our work on the transformations we use to find a range?
Yes, you can use it. Yes, definitely. Well, the point is that when you have the transformation trick will be useful if you original function, you know the range for that. Okay, if you don't know the range for the original function, that will work. So it is possible to find the range of a function after doing some transformations. It will be definitely helpful in computing or calculating the range.
All right, I think questions related to this problem is finished. Or sorry, it's just a follow-up. Why are we using g of x to find h of x's range?
Because h is defined in terms of g. We don't have any other information. Everything is defined in terms of g as this equality is given. And we are trying to say that, okay, I can get h by doing some transformations on g. Okay, this is how you get that. Now, each step, which is a transformation, will change or won't change the range. I track that thing, and at the end, I found range for h of x which is negative a2 plus infinity. Okay.
Is everything clear, guys? So Yasmin asked, in the assignment, do we have to show this much work? The grader.
Okay, so first of all, in the assignment, written assignment, the more good work, not garbage, sorry. If you put good work, you put as much as you can. That's helpful for the course, the assignment grader. And it will be good for you if you have made some mistakes, you will get marks for steps that you have done. But in general, the rule for assignments is that show your complete work.
All right. Another question is, what if we were talking about a rational function and that there is a vertical asymptote at a certain point?
What if about what? Sorry.
What if we were talking about a rational function? I'm assuming he's talking about the g, or maybe, I don't know. If you could clarify the question, maybe it would help. He says, all right, what if h of x was a rational function? All right.
It will go the same way. This question is very general. G can be any crazy function that you consider.
I think he's talking about h. Like if h was something like 3g over 5 plus something.
Oh, if it was like that, the transformation wouldn't be able to find. Like, are you talking about like gx plus 1 over 2 gx, for example, minus 1? Something like that?
At this point, you can also unmute your mic and ask if you are comfortable with it. Yeah, he says yeah.
Oh, no, in this case, so this cannot be done by the transformation. No, that cannot be done with the transformation. Okay, so let's call the day, Sinan, at this stage. That's okay.
All right.
Okay, yeah. Let's call the day. If you guys don't have any question, you feel you want to leave, you're free to go. This is the day, but we will, hopefully Sinan will help me a little bit more. Good.
No problem.
We will be here for another 5-6 minutes.
All right. There are some questions about quizzes and assignments.
Okay.
I think we're done with the course material.